application suite. Yeah.
Like on the side of the last screen, it shows check marks for making backtrack. Is there a little X of that if they haven't found?
That's the goal. So here we can look at Ed, or we can look at the whole class as a whole and see kind of how it went. Are there any questions about Central Park?
The yellow triangle.
So a yellow triangle is a warning. This is for the teacher looking at this, and we can say, you should maybe look, this student was not able to get this equation right. So this is our X, but it's not really an X, this is a conversation we should have. Any other questions? Really far away. Yeah, so I just typed in h comma k and then pressed to add sliders for both of the values. Yeah, so let me go through that process again. So here I'm going to get rid of this column. And actually I'm going to do one step less advanced than this, is I'm going to just make a slider for A, and I'm going to make it equal to 10. Exactly. So here I type A equals 10, and now instead of being at 7, 10, I'm going to make it at 7, A. And so now when I change A, everything's going to update. Yeah.
I'm not familiar with revenge.
Community's revenge.
Where you do just measure their height versus their length.
Okay.
Their arm. And there's always outliers.
Yeah.
The whole point is to find where the outliers are. It's not necessarily a stat, it's more of an 8th grade math problem.
Yeah.
This looks like very good for that because the students can see where the outliers.
So that's the goal. One of the things we really wanted here was to make it easy to start introducing the concept of models and best fit lines much earlier by making it much less of a barrier. So we had a question about can it do other models? And I'm going to show you the way that we do other models. So first I'm going to go back and put this. Let's say that we knew for some reason that the intercept of this situation was 0. We know that it goes through the origin. So instead of being a linear relationship, it's now a proportional relationship. And so that one, instead of looking like y equals mx plus b, it's going to be y twiddle mx. And so all I do is I delete the b, and now it's going to tell me what m is. So now it's optimizing for m. It just has that, and it shows us now an r squared value because you can't show a correlation coefficient unless you're actually doing a linear fit. So now we show you the r squared. And let's say for some reason we thought that it was a parabolic fit. So I'm going to go here and change my mx1 to an mx1 squared. And now it's going to find the best parabola. That's actually a pretty bad fit because the only thing it can adjust is this m. And there's no m that makes this look like a parabola. But if we changed it to maybe ax1 squared plus bx1 plus c, now it's going to find a parabola that goes through it. But maybe you didn't want it in this form where it's a, b, and c. Maybe you wanted it in vertex form. That's never been possible before. But with this system, the way you do that is you just write it in vertex form. So I'm going to change this to a x1 minus h squared plus k. And now it looks exactly the same, but the things you're getting out are h and k, and maybe those are meaningful parameters. Maybe in this situation those are. So I want to show you a couple ways that we can apply this.
That is killer.
Will it show the other one too? I want to go over further. Will it show you the other?
Any function would do this. Square root,
Oh
logarithm,
yeah, so we can just click and drag
exponential.
to slide the graph, and now we can see where this model intercepts with 0. So let's actually apply this to some actual data. Here's one that came in the other day of the daylight hours in somewhere in Northern California. I forget where. This is by month over the course of a year. So this is another feature we just added. I'm in Google Docs right now, and I'm just going to Command C to copy, and I'm going to go back over to Desmos and Command V to paste, and it's going to put the data in.
Nice.
And this looks to me probably like it's a trigonometric function. What form would you guys like me to type in for a trigonometric fit?
Y equals sine x.
Y tilde sine of x.
Okay. A sine x.
Okay. Let's add a plus b. So it's going to get better. Let's maybe add an a. That still doesn't look that good, huh?
No.
So
X minus H, X minus C.
So we can do that one, but there's actually another one that's really important, which is the frequency of the curve.
Oh, right.
And that's the parameter that we multiply this by, and as soon as I add it, it's a perfect fit.
Oh, nice.
So we can do it in that form, but if you like the version where you have the frequency outside, you can do it in that form, and now it's going to recompute everything, and you still get the coefficient.
Can you change sine to cosine?
Yeah, let's change sine to cosine. Is that gonna shoot?
I have no idea. It didn't work on Wednesday, but.
There it is. So now we can do it as a cosine.
Just change the C.
I wish.
Let's do one more. This one's a little bit more terrifying, but we're going to try it. So here is a graph that someone put together, a data table that someone put together of Ebola cases by day.
In the
So
world?
there's a lot of claims that this is exponential, but let's see how exponential it actually is. So here I just transcribe those. I go back over to Desmos, and I'm going to paste it. And it definitely looks exponential, huh? But let's see if it is. So, favorite form of an exponential, anyone? Y1, twiddle, a times b to the x1. And there it is. 0.994 r squared. We've got some parameters in here though. B, 1.03. What does 1.03 mean for B? So to basically look at it, inspect it, figure out what it meant, interpret it, and then come to some really meaningful quantity. So I leave it as a challenge for you guys, because I want to leave some space for questions. Challenge for you guys. Are humans on this curve? How many beats per minute is the average, or how many beats in their life does the average human have? I don't know. I don't know what the answer is. I think it's a lot more. I hope it's a lot more. We've been working on this for a long time. We've got millennia of trying to. We've got to space out.
There's a couple old people today when I parked. What you guys doing? You got
Yeah, and I love that. So let's try that one. 48 divided by 4 minus 6 divided by 4. That one also works, and it looks completely different. And now you can talk about equivalent expressions. Yeah.
Say that we just have,
This is really neat.